What is up, guys? Welcome back to Vanover Machine and Repair, and welcome back to our continuing Lion lathe project. Now, if you've caught our other videos, we have done a ton of upgrades and modifications and repairs on this machine, and in this video it's our goal to wrap up all the loose ends and finally put a lid on this ongoing project so we can move on to bigger and better things. Let me bring you in a little bit closer and we'll talk about what we've done up to this point and what we're going to be addressing in today's video. Right off the bat, I just want to state the obvious. Owning this machine has been a roller coaster. I was very happy to get a brand new machine in the shop. I absolutely love lathes, and I tried to buy the best lathe money could buy. Obviously, the top choice would be something Japanese, but they don't really have manual machines here in America that are made in Japan, and this was literally the best machine that I could find. And this machine, as you've seen in the other videos, has come with tons of problems. I've had a boring mill project that's been put on hold while we address this machine and other things that have been put on the back burner so we can make this machine right. By the time we're all said and done, I'll probably have about 400 hours into fixing and upgrading different aspects of this machine, and maybe $5,000–7,000 of investment between parts and Daniel's time, and it just seems fairly excessive. Now, I am aware that I am a very particular customer, but also I am a machinist, and the machining field is a pursuit of perfection. And I know that when you buy anything new, it's never perfect, and a lathe is no exception. And I'm also aware that the level of manufacturing was much higher 40, 50 years ago. Even so, when you spend the amount of money that we spent on this machine, you would expect a high level of quality, especially in the areas where it matters most, like the scraping, which was definitely shortcutted on this machine. So as a result, because this is an investment for us, I want this machine to operate as good as possible, and I don't want it to wear out prematurely. And that is why we've taken the time to redo stuff that I could have just let good enough be. But we want to get it scraped. We want to deliver good oiling, so that way in 5 or 10 years, this machine is still as tight as it is today. So with all that kind of out of the way, let me give you a recap briefly, if you haven't been following along, on some of the things we have done up to this point, and then we'll jump into what we need to wrap up in today's video. So far, what we've done is we've re-scraped the top slide, the top of the apron, the bottom of the apron, the compound. I don't know if I showed that. We've re-scraped the bottom of the tailstock. We've manufactured a brand new coolant tower and setup, a new arm for the DRO mount. We've engineered and made about 12 different brackets. Most of them have been for cable management, oil lines, shields. We manufactured 2 different mounts for the tag-along feature, which we lost because of the DRO installation. We made a brand new coolant pan, and there are several other things that I didn't even list that we did up to this point. Now, what we need to do to get a giant red bow on this project and send it down the road is we need to finish up some wiring for the airlift. We need to finish up getting the coolant tank over here and installed and wired up. We need to install parts for the cable trays, tag-along tailstock, coolant tower, DRO bracket, and basically finish that whole assembly. We need to verify the operation of the tailstock and cross-slide single lubrication system. We need to run the plumbing for the actual coolant tank and make sure everything is tied in. And a lot of this stuff has been kind of mishmashed. I've tried to do my best to organize this, but a lot of this work has gone on over 3 or 4 months, and I'll get a break in jobs and we'll do some work, and then Daniel will come in, he'll do some work, and we kind of need it all to come together right here at the end. and that's what we're going to be doing in today's video. So let's jump right in, and we're going to start out by working on the wiring for the lube pump and getting some of the wiring for the 110 volt solenoid for the airlift. Taking a look at the back of the machine, we have done a significant amount of work on the wiring, and we still have some work to do. Mainly, we were able to run this additional piece of conduit which houses the wires for the cable tray we deleted on the front. And the nice thing about this is going to allow us a cavity to run additional wiring, air lines, and oil lines, and potentially some of the coolant line over to the middle of the machine where they can pick up on the secondary cable tray we're adding in the back. In terms of the actual panel, we're going to be replacing one of these overload protections with this guy. The overload protection for the coolant pump is only rated at 0.5 amp, and we have a factory unit that's a direct replacement that goes up to 1.6 amps. So we'll be able to run our larger coolant pump. This will be pretty plug and play, so that's not too bad. We also have 2 relays. We're going to be using these relays to interface with a 110 volt circuit and be able to give us switched power when the spindle is on. And that switched power will be used to operate a limit switch, not this one, and our coolant pump. Now our limit switch is going to be used, and it's going to be powered up only when the spindle is running. That limit switch will be set up on the tailstock lever, which is going to be super tricked. So when the lever is down, there is airlift, and when you pull the lever to lock the tailstock, the airlift turns off. So lever is locked, operates normally, and then you want to move the tailstock, you just move the lever back and the airlift will be activated. And because we're going to be running this off switched 110 volt power, when the machine is off and the lever is down, the airlift would be on, but it will be off because the machine is off. So that's really, really nice. For our lube pump, we're going to be running this pump. It's the same pump that I have on the pacemaker. It works super well, and more importantly, it's a stock item. So if it fails or goes bad, it's pretty cheap and pretty readily available. We're going to take this guy and mount it somewhere over here or over here, I haven't decided yet. This will allow easy access to get our oil, and because we're running this off of switched 110 volt power, the actual timer that is set up in here will only run when the spindle is on, and it remembers that time. So when the spindle is off, the timer stops, and we're going to probably set it up to give it a burst every hour. That's what's worked on the pacemaker, and this will deliver pressurized oil to the tailstock and to the top slide, which is going to be super, super nice. So the first step is to get this bad boy mounted, and then we need to mount a 110 volt box over there and then run some cabling into here so we can make that box switched. All right, we did some work here on the back, did not film most of it because it is really cramped, and I'm going to walk you through what we have going on. Currently I just have a wide shot here so you can kind of see everything and how it's positioned on the machine. One of the main things that I was concerned about is we needed to add a fair amount of things to the machine, but I wanted the machine's footprint to remain as square and clean as possible. That way, not only when I'm looking at the front like I am now, or I guess the back, not only does it not look cluttered, but if we ever need to get this machine against the wall or move it, I didn't want a bunch of junk hanging off the back. Mainly because if you're walking back here, you don't want your pants or your jeans to catch on anything. So I wanted to keep it nice and low profile. But we are doing a lot of modifications back here, so we spent some extra time trying to integrate everything so it's nice and clean. We'll start with the air and the oil. So let me kind of show you here. It's a little cramped back here, but you can kind of see. So over here we have a regulator, and this is specifically for the airlift on the tailstock, but I wanted to make it nice and easy and very modular in case we decide to make any updates. So the air hose comes in here. That just brings air to the actual machine. And then we have an extra port at the top in case I want to add any air accessories in the future, and that air port is unregulated. Then we come down to this regulated air, and we have just enough clearance in here where I can adjust this. I can read the gauge. We're not interfering with the chip pan if we need to remove it, and we're good to go. Now obviously if I need to swing this cabinet over, and you can see it's on hinges, we are blocked, but that should really not be something that we're ever gonna do. I had to do it to relocate some wiring deep in the machine. I don't think we're gonna be doing that, so I don't think it's gonna be an issue. We have our solenoid, and our solenoid is just an off-the-shelf solenoid. Same ones we used on the boring mill. They're very cheap. They work just fine. And more importantly, I can keep 5, 10 of them on the shelf, so if they ever fail, they're really easy to change out. So coming out of that, we have our exhaust port, and we have our one air line, and then this is how we're powering this, or switching it, or however we want to call it, and that's a 110 volt line. So our 110 volt line goes down, and our air line goes down. I tried to add as much of this cabling, so that way if there are any stray chips, it minimizes where it can damage an airline. So moving down, you can see we have our oiling system back here. So this is really nice because it's nice and flush with the machine, and it's really easy to fill. So I can just pop this cap, and right from the edge of the machine I can fill it, and that's really nice. And the screen and everything can be accessed. There's actually an angle here, and it works out really nice. So if you come along to the front, so you can come in here and adjust everything, and you can see the pressure if you need to. But once we set it, you don't really need to work with it, but at least we didn't block that accessibility. So kind of coming down below, you can see that we have our oil line coming out of that oil pump, and we actually ran it into the box, and we'll get to that in a minute. And we did that so that way you can actually have minimal oil connections kind of flopping around in the breeze, and we're trying to minimize all the extra junction boxes and extra things we need on the back because we have a lot going on here. This is the airline that came down, and it also runs into this box, which is really nice and clean, and we got these shielded in these nice flexible stainless wires. Now if we go a little bit deeper, you'll see that we have an additional box back here. It's kind of hidden. And right now I have it down, but there will be an outlet that's gonna live on the cover of this box, and I'm waiting to just have Stefano come out and double check my work. But we have everything labeled. So we have the oil power, we have the tailstock air power for the solenoid, and you can kind of see up in here that these lines run into this box. And then we have a third line running in, which is a power cord. So that power cord is bringing 110 into the machine. We talked about this a lot and went back and forth, and ultimately because of the way the machine is set up, it was just gonna be a pain to try to suck 110 off the machine because the transformer is set up for 24 volts. It's set up for 12 volts and also 220. So we just opted to bring in one extra cord to simplify things. So we have our 110 coming in, and then all of these connections are going up into over here where we have another feed from that 4-inch box up back into the panel, so we can make our connections and basically toggle on and off that solenoid and also that oil pump. So now let me show you the inside of the panel and how that kind of finished out. So taking a look at the panel, so you can see our wires come in here, and this is the wires for switching our oil pump and our solenoid. Those wires are going to come up into this cable tray, which is already existing. And then on the top here, we have a nice set of relays. These relays over here are going to actuate both of those things. The reason why we're doing this is because I want the oil pump and the airlift to only be on when the spindle is running. And the reason for that is this panel on the back I keep live. We go ahead and close this and I keep the panel on so I can easily come up and turn the machine on and it's nice and ready. But while the panel is live, I don't want my oil pump timer going, and I also do not want my airlift on, because it's going to be normally on, and we'll get in that in a minute, but I only want it normally on, or air being powered to the tailstock when the spindle is running and I'm working at the machine. So these two relays will take a low voltage control circuit off the main contactor, and they're gonna bring that control circuit up, and that will switch these other lines over here on the side to turn on and off those two items that are 110. So now let me show you how we routed the air and oil from those two things. So if we look deeper in the box, down here, you can see we have these two plastic wire nut, I don't remember the name of what these are called, but everything is interfaced with the box with a connector like this, and we have our air line and our oil line coming up and then going down into this conduit, which is over here on the side. And this conduit we put earlier, we added this so we could relocate that front cable tray, and we're using that conduit, and I'll shut this box. So we're using this conduit here to pass not only the wires that we relocated, but also the oil and air lines, which is really nice because it's going to minimize stuff that we have hanging down here on the back of the machine. So right now, if you kind of look at the back of the machine, we have kind of a lot of cords going on, and the reason for that is we're kind of in the middle of just getting this wrapped up. But the other cord we have hanging out here is this red cord, and that cord is powering the DRO. So instead of running two extension cords, we're going to just use this one black cord, and we're going to actually plug the DRO into a live 110 outlet that's on the front of that panel. So that'll simplify the wiring there. So really on the back, the only rubber wire or SO wire we'll have is that 110 cord, and all the other wiring you're not going to see. And if there is any wiring, it's going to be inside of this conduit that is pre-existing, and it'll be nice and shielded. So continuing on, our oil and air line, we're going to run down this line here, and it is pretty tight back here, which is part of the reason why we didn't film it. But I'm going to kind of show you over here, and it's pretty dark as well. So those air lines are going to run all the way over here, and if you can kind of see here, this is the air line. I just have it coiled up right now because it needs to go in the cable tray going over to the tailstock. Comes out a little hole in this. This I made in a previous video to kind of continue on our wiring. And then this is stainless. You can barely see it off camera, which is really nice. So this is going to power a manifold, and that manifold is going to control our oiling. There's actually a tray that covers this. Probably be good to show it. So this tray is going to come up here like this. This looks really, really nice, guys. This cable tray mount is going to feed our main cable tray for the lathe, and as you can see, everything is positioned really nice underneath it. Our air line will come up through there, and then over here as well, which you can't really see because it's not here, our coolant line is going to come up here as well, and then we have a hole in the bottom of this guy, and those will come up through those holes and basically feed out the front of this cable tray, so we can get coolant, we can get air, and we can get oil over to the carriage, and that can be on a cable tray, so it can move in and out and never ever get snagged, which is super, super nice. So currently I have a couple ports just temporarily blocked off, but if I want to do any metering, it's going to be very, very easy. Currently, we're probably going to just use two lines and run no meters, which is what I do on the pacemaker. It's a little wasteful, but I'd rather have a little bit too much oil than, not enough. But if we feel like it's excessive, all we have to do is figure out what the meters we want to run, and we can just run normal meters. So it's really, really trick. So one of these will go back to the tailstock, and then one of these will go to the top slide and nut area on the carriage / top slide. So that'll be really, really nice. And if we ever want to oil anything in the future, I don't think there's anything else we could oil, but we have more ports in case we change our mind, or let's say we want to divide out separate lines for some reason. We have it there and it's nice and easy. So that's how the back finished out, and it's going to be really nice to have this covered. You won't even see it, chips won't be in the way, and everything on the back of the machine is going to be very clean, very protected, and it's going to be really, really nice. Well guys, it's time. After months of working on this lathe, hopefully today we're going to be drawing this to a close. And the next step is the exciting step. Daniel came in here, he did his work. We re-scraped the tailstock, we re-scraped the apron bottom, top slide, top, bottom, and he's gonna take the compound and take care of that next week. But for all intents and purposes, the repairing of the machine is done, and it's time to install all the upgrades that we've been diligently working hard for the last couple months on. So before we go ahead and make those installations, I just wanted to take a minute and talk through each of the parts that we made. I have laying on the table behind us, and we'll kind of give you a rundown of the individual parts and their purpose, and then we'll get to installing them. Here's a quick shot of the coolant tank. I'm not going to talk about this too much. We already went in depth on this on the previous video, but you guys didn't get to see it finished out. Turned out really nice, getting everything painted. Couple quick notes. We went ahead and added a gauge to the front so we can see the coolant level, which is really nice because this is closed, and it'd be cool to know where our coolant level is. And then over here at the coolant pump, it may not be obvious initially, but we actually have two outputs. One output is going to come to a hose. That hose will be like a wash down, which will be really, really cool. So if we want to clean the lathe off with some coolant, we'll have like a hose nozzle, and we'll coil that up and leave it in the tray. And then the other one is an output over to the lathe. Other than that, we got our coolant paper laying in there, or fabric, and that's going to be really nice. Looks great, and it's going to be a huge upgrade. So I'm really, really happy with how this turned out. All right, we got all the parts that we had to make on the bench here. I don't know how many it was. It was like 15 different parts, and we're just going to go through each one of them briefly and kind of tell you a little bit about it. Took quite a long time to make all these parts, but I think it's going to be really, really nice. And we went, you know, as overkill as I typically do, to produce quality parts and to really make sure they're engineered properly, and they're going to do a really good job. So let's start off with this main sort of piece here, and this is a billet cable tray coolant passage mount. This thing is extremely over-engineered, and I was advised against making it this way. This part is, I don't know, 25 pounds of just solid steel for absolutely no reason. Well, really the main reason is our coolant tower is going to mount to this right here, and there's a lot of leverage because we have 18 inches, and then we have a Newall arm that is 14 inches, and I didn't want this Newall arm bouncing around and flexing, so we made this overkill so that way everything would be nice and rigid. This part I actually did have made in China at a CNC shop. I was super busy at the time, and they were able to knock this out for less money than if I was to buy the material. And I'm really, really happy that I did that because it got the result done, and it would have taken me a really long time to make this part. And at the end of the day, it's beautiful, but it's just a functional bracket basically. And the weird shape is to dodge the taper attachment that passes through here. So a cable tray will come in through here, and our wires, coolant, hose, and oil passages will come out this back part. Our coolant will pass through here and then come through here and up our coolant tower, and then all of our coolant lines will be able to reach the back of the apron where they need to. So this piece is kind of like what everything is built off of. And we did a fair amount of engineering just to make sure it would fit and line up and bolt up to factory locations and everything works really, really nice. So that's that. We have a nice custom NPT 45 that's really nice. Looks a lot nicer than just like a piece of pipe elbow, but that's this main piece. Moving right along, we did a separate video on this, so we won't get too much into this, but this is the coolant tower. If you want to see how we made that, we made this from one piece. This coolant tower is going to bolt to the top of this, and this thing turned out absolutely stunning. We made this in-house. We got it chrome plated, and it did an excellent job. Here is the updated new wall style arm. Now this arm is a little bit different than a new wall one because we have a nice shoulder bolt there. So that interfaces over here with this shoulder bolt, which is just a little bit more smooth and trick. It's a really, really nice friction feel. This arm moves really nice. We have a wave washer there to dial it in. And then on the back side, we have some undercuts, and we have the same style of plastic clips that pop in. The new all one has some slots for zip ties, which is totally fine, but this is a lot cleaner and just gonna look really, really nice. These clips here are 3D printed, and they clip in here and they snap in, and then this one snaps in for these two. Right along on the front here, we have two brackets here. These are the updated tag along tailstock feature. Basically, when the machine came to me, it was disabled because the DRO is in the way. Well, who doesn't run a machine like this with a DRO? So I wanted to retain that feature, but you gotta be a little creative, not crazy creative, honestly. But you gotta make a custom bracket because the bracket that they ship won't fit. And so we engineered a bracket up, tested it, 3D printed it, and obviously these are metal. So those are gonna work really nice. And then I don't know how well this is gonna work, but I opted to do a slot here. So these kind of come together, and I wanna do like a 3D printed sort of washer or wedge or key or whatever. So that way if there's too much force, it can break. But yeah, I figured with the slot, it gives me a lot of options. If that doesn't work, we can just make a metal key that sort of drops in there when these come together. So that worked out really nice. We 3D printed a custom cap for our coolant pump. The coolant pump had a cover with fins on the top, but that's going to be a problem because it sits up and chips come down. So we just designed this up and 3D printed this in ABS glass fiber. It did a really great job. It looks great. And we have air ports on the side so that the air can expel out the side, and the top where the chips land, it'll keep it out of the fan. So that's that. Moving right along, we have some more cable tray parts. So this is the factory chip tray. We went ahead and made this part, CNC machined the logo in here and welded it to this. So this part turns and sits down in the back, and the cable tray will come out of this. Will come up, loop up, and link into this area over here. Moving right along, we have this guy right here, and it looks like I still have some tape on this, but basically this is a cable tray for this smaller miniature cable tray, and this miniature cable tray here is for the tailstock. So we're gonna have airlift on that tailstock. We're also gonna have powered lubrication, and we need to get those lines to the tailstock. So we have a miniature cable tray. It's really, really cool. Actually, that cable tray, we have a big cable tray here, and then right above this and actually over to the side, we have a little baby cable tray that kind of worms its way in between this and the carriage. So that's really, really cool. Moving along, continuing the cable tray theme. This cable tray, obviously we didn't make it, but we made a female receiver. So kind of like one of these guys. This bolts to the tailstock, and this guy interfaces into the back, and it's a nice tight fit. This is also 3D printed. Turned out really, really nice, ABS glass fiber. Now, one of the problems that we're gonna have with this cable tray, and there's not really a good way around it, is it's gonna be exposed like this. and then obviously roll up. But chips can get in here, and they don't make metal cable trays in this size. So what we did is we have some stainless steel, and the stainless steel is gonna lay and cover this and sort of give this some rigidity and block the chips. So we 3D printed up these little clips. These clips slide onto here, and then basically they're gonna keep this metal, whatever we want to call it, in place so that it stays, and that'll be really nice. So we 3D printed a bunch of these. We also made this, you know, billet, completely unnecessary chip shield. So when all this stuff is on the tailstock, which you'll see here in a minute, we wanted to keep the chips at bay. So this guard bolts to the side of the tailstock and kind of keeps the chips, you know, out of our wires and all that kind of stuff. So that's unnecessarily overkill. Our last part here is a 3D printed holder for our proximity switch for the airlift on the tailstock. So there's a hex in the back, and our sensor slides in there and then tightens up on the front, and works out really, really nice. So overall, we got all these parts done. I got them tested along the way, painted, finished, whatever we needed to get done. So the next step is to go ahead and get these guys installed, and we're gonna start with this part right here and get that bolted up to the back of the carriage. All right, we're making some progress here. Let me bring you up to speed. A lot of this is a little hard to film here in the back, not the most exciting, but I'm trying to show you what we're doing and how we're bringing it together. So this is pretty much squared away. We got the DRO set up, we got the arm on, we got the wiring set up and the coolant, all the wires run through the cable tray, and we're pretty well squared there. We have a couple minor problems that I didn't see around the corner that we're going to be addressing. One of which is I have a meter installed in line here in the center. This lubricates the nut. Each of these lubricate the way surfaces. And when you traverse this all the way to the back, this extension hits the splash shield. We're about maybe an inch too long. So instead we're gonna run a Your Lock that's a 90, so that'll give us just a little bit more clearance. So that's really easy to fix. Also, our cable tray over here hits the back splash shield when you bring this all the way to the most extreme position, which it's not gonna be, but we don't wanna set it up to where the machine can't operate at its extremes. So we do need to modify or clearance the cover there. I knew it would be close, but I do think it's gonna hit. So we need to take care of that. Other than that, everything else is coming together really, really nice. The resistance on this is really good. This looks really good. It's nice and rigid, nice and clean. A couple of you guys may notice this seems a little high. I'm tall, and the way the machine is setting up, this top line here is just a little bit below my eyesight. So it is perfect for me. And more importantly, it'll be nice to not have, you know, a coolant line coming past there. Everything is nice and integrated into one piece. So that's really, really cool. So next step is to work on the tailstock. So we have 2 wires, 1 air line and 1 oil line we have to bring to the tailstock. One is for airlift, one is for powered oil to the bed, and these 2 wires are for our proximity switch to operate the airline. And we're gonna be doing that through a cable tray. So the next step is to get our additional cable tray mount and get this guy installed and interfacing with the actual tailstock. All right, let's get in our cable tray holder for the little baby cable tray. All right, there it is. All right, we're gonna remove this PLA bracket and install the updated part. All right, here's our new bracket, printed out of ABS. Nice and rigid. And then we have our wires here and our cable tray. Okay, there we go. I'm gonna go ahead and add our stainless piece here to the cable tray. And then we'll go ahead and get everything wired up. All right, we got this squared away, and I'm gonna be the first one to say, I don't know how well this is gonna work. This was some of the last stuff that I put together, so if it fails, well, then we need to find out another solution. I think it will work, mostly because this tailstock moves back and forth in a straight line. So I think this will just operate properly, but I don't know. I think the stainless is good because the chips can come down and blast this, and I don't have to worry about it melting our plastic. Now we do have plastic exposed up here, but I would think most of the issue is on the down low here, and as we come back, that's protected. The clips worked out really, really nice, but I think the main con with this guy is this thing is long and floppy, and it needs to be, so that way the tailstock can go really far in comparison to the carriage. And I thought about maybe taking this and setting it up at the back so that it's tied to the back, but we would have the same problem. So this is the most efficient way to do it in terms of the space and in terms of it not sticking off the back as far as having it feed off the carriage. But as a result, you know, we have kind of a floppy deal here. So maybe it'll be just fine, but maybe it won't be. So now that this is all set, the last step is to add our sensor in here for the handle and replace this and do our 2 push to connect fittings, connect this, put our guard on here, and we should be pretty much good to go. All right, next step is to install our proximity sensor here. And instead of a limit switch, we decided to go with a proximity switch. So this is exactly what it sounds like. Basically, this sensor will monitor this handle. And when that handle lifts up, it will disengage the air assist. Just get this a little bit closer. There needs to be an air gap over here of a certain percentage. Top port is for air and the bottom port is for oil. So we're gonna come in here and let's just see, are we gonna be able to make this radius? Yeah, that's fine. I have some 90 degrees if we need them. All right, it's our lube line. So the thin one is our lube. So let me cut it long first. Okay, yeah, it's a little long. Shorter then, okay. Now our tailstock is oiled. All right, and our top one is for the 6mm hose. That is for air. Okay, that looks good. That looks real nice. All right, the last thing to do is to solder this wire. And we have our shield here, kind of blocks the chips. So I'm gonna go ahead and solder these 2 wires together, nothing crazy, and put our shield on here, and then we'll bring you back. All right, this is how we finished on the back. We got our nice chip shield to protect all this, and we got our limit switch there, so when we operate the handle, that should work pretty good. So we're pretty much done back here. We're gonna go around to the front of the machine and start testing this stuff, make sure everything works. All right, guys, well, we had an issue here. I had our cable tray all set up, and that was a disaster. I wanted to use this stuff because it had a tight bend radius and it was small and I didn't need anything big. But the problem is this stuff is just too flexible. So off camera, I scrapped that idea, picked up $400 of larger cable tray, redesigned the mount here, and made a new chip tray, and we are gold. This is nice and rigid. It's not gonna fall off this aluminum rail. It looks great. It's super overkill. We don't need something this big, but I went with something a little bit larger to give structure, so that way this doesn't fall off that metal DRO bracket, because it lays on there and it kind of has a nice body, nice and rigid, which is exactly what I wanted. So we got all this squared away and I'm very, very happy. That was a dicey day or so once I realized that this wouldn't work, and I wanted to get the machine up and running and I didn't want to have it down. So luckily I was able to get this squared away quickly, and that's the last real thing. We're gonna get the chip tray slide out and get our new coolant pan slid in, and we're pretty much ready to go at that point. And we can start making some tests and see how everything is performing. Well guys, we are here. We are at the end of the work we're doing on this machine. And I know that work always continues, but we're calling it, and we're calling it quits here. We've been working on this machine since May. Today is November 1st. We took delivery of the machine sometime around the end of May, I think, or beginning of May. And we used it, we worked on it, we used it, we worked on it, we downed it, we worked on it a lot. And it's just been a whirlwind of upgrades, issues, fixes, improvements, joys, stresses, and overall, I really, really like the machine. And especially now that we've made the changes and adjustments, that is contributing to the way that I like the machine. So I want to just wrap this video up talking through a couple points, some stuff that I've done since the last shot. In the last shot, you've seen me messing around with the cable tray in the back, and it's been about 3 weeks, and we've done even more stuff. And I'm just gonna run through it real quick and kind of give you some updates, and then hopefully we can kind of put this machine to bed and move back to the Lucas and eventually move back to the Lion lathe and get on with the rest of the stuff we need to do in the shop, which is many. I'm just gonna share the mistakes that I made, somewhat recently in regards to the machine. The coolant tank, you saw me get it in. The coolant tank, I used it for a couple days. It works amazing. It's great, but it leaked. It's crazy, right? All that waterproofing, all the caulking, everything we did, it leaked. And it wasn't much, but basically I had a puddle over there on my shop. It's kind of sloped that way. And I saw that it wasn't going away. So I pulled the tank out. It was full of 80 pounds of coolant, or 80 gallons. I raised it up with the jib crane, and lo and behold, there was probably 100 bubbles underneath. So there was no large leak. However, what had happened is I didn't paint the bottom because, well, I didn't care about the bottom. And on the bottom where I did all the welding in the center for the support, there were a bunch of pinholes, and those pinholes were really, really tiny. And so there were a bunch of bubbles. So off camera, we pulled the tank out, we stood it up, we drained the coolant. I got the coolant in jugs, and I went and I waterproofed the bottom. We sealed it, we water tested it by floating it in the air, inspecting it. It doesn't leak anymore. The other issue that I had after using it for a couple weeks was the grate that I put in the middle was a fantastic idea. In terms of drain back, amazing. The old one, terrible. However, that drain lined up dead center, just by chance, of the center of the lathe. And what that meant is that all the chips landed directly on the grate, which is fine because the grate is there and we had that white sheet. But what I saw was long term, we're gonna induce a lot of chips when we don't need to and make it difficult to clean because majority of our stuff is falling on a perforated sheet. So what I decided to do is I just fabbed up a real basic piece of sheet metal that lays on top of that and kind of makes a flat surface across two planes. So now when the chips fall, there isn't any grading. It literally just falls onto a flat surface. So when the people come in to clean, they can come in here and they can just wipe right across and it's smooth and they can clean the chips out. And every once in a while, I can pull that flat grate off and underneath is the grate. So that will prevent the chips from actually going into the coolant tank, and we still have our white paper on top of that. But 90 to 95% of the chips won't even make it to that point. And because this flat plate has such a large surface area, the drain back is not an issue. That was my initial thought, was I wanted a lot of open space for drainage. But really the problem with the old tank was just surface area in terms of the drain back. But because we have such a long drain and because this flat plate has such a big surface area, even if the water comes and wicks its way around, it drains back fast enough, so that's completely fine. So I think the tank, pretty much golden at this point. The gauge on the side, super nice. I can see what my level is. That is done. In regards to coolant, we had issues, right? When you make upgrades on stuff, you find the break points, right? If you add 1,000 horsepower to your Supra, it's gonna be sick, but you're gonna start breaking drive shafts. And that's the way I roll. I'm over here upgrading things, changing things, altering the structure of the machine. But as a result, we find problems, and then we solve those problems. So with the coolant, I added a motor that I got on surplus. It ended up being a 1.25 horsepower. It was in, not metric, but it's European, and it just gave a wattage. I had them sitting on the shelf. I wanted to upgrade, and I did it traditional Kyle style. I went way overkill. Well, the problem with that, because the old one was kind of small and weak, and I way overdid it, was the power of that coolant pump was crazy strong. So when I hooked up the coolant pump for the first time, and I didn't show you this, and I turned on the coolant, it shot out like, you know, crazy. And then when I closed the valve to deadhead the pump, for 4 seconds, it burst the coolant line. I've never seen that in my life. It had so much pressure from being deadheaded in that short amount of time that the coolant line ruptured. So I knew that had to be remedied. So basically what we did, I took a T in line and I routed a hose back into the tank. So now when you turn on the pump, like, I don't know what percentage, but a significant percentage of the coolant coming out just returns to the tank. And where that's really nice is if you shut this valve, there's kind of like a bypass. Now, I thought about doing a check valve or a pressure relief valve and all that, but honestly, it's very simple. It's just a T-fitting and it's just a drain back. So when all the valves are closed, there is a way for pressure to sort of release. But even in doing that, even though we have about a 1/2-inch hose going back into the tank, we still have tons of pressure up here, plenty. So we figured that out. That's taken care of, no issues there, and that could have been bad, right? If the thing is that hose burst down below, it didn't burst inside of our cable tray, so luckily it wasn't worse. Otherwise we would have had to refish that and do the whole line, and so it was a whole thing. In regards to coolant, now that we have more pressure and now that we're running coolant a little bit more chaotically, it's just getting messy over here, right? And I knew that would be a problem. The machine came with a guard that Josh told me not to remove because it does a great job containing coolant, which it does, and it would solve my problem. But the problem that I had is the guard's in the way, right? I like to be able to come up to the machine, use the chuck, you know, look at what I'm doing, and I'm super glad that I removed that. But in removing that, I lost sort of that benefit of containing the coolant. So now I have a guard removed and I have even more pressure. It was literally like a bath. I have an 80-gallon tank over here and you stand right here and you just get soaked, right? It's like you're a water park. And not only that, I'm draining the tank because now I'm throwing coolant all over the shop. So I spent a fair amount of time thinking about how I could add some guarding that would not impede usability of the chuck and standing near the machine, but help mitigate some of the coolant. And really what I realized was there was 2 different categories. One, permanent guarding. So we added this and we added this, which stays there all the time. So that just helps in general, not soak the wall behind me. And then over here I can get my chuck wrench in, right? And I can come up to a little bit less than half, right? And I can spin my chuck wrench here and I can position it and spin it. So I've got tons of access, right? And then I have the 3D printed ABS piece right here, which is really nice. I can actually balance my chuck key here and I'm riding on a nice piece of plastic, right? And it's not impeding and everything is golden, right? So we did some permanent guarding to kind of mitigate that. But more or less, when I machine, if it's OD work, I'm generally not using coolant. Usually I'm using coolant during heavy boring cycles, and I got heavy drilling for sure. So I went ahead and I took the portable sort of like splash shield and I modified it by adding a top and a bottom. And a couple of you guys asked what this pin is for, and this allows me to have a removable sort of splash guard. And this was factory, so I can come over here and I can add this. So when I'm doing this repeat job that I have where I do these spacers, I can come over here and as you can see, a lot of this is covered now, but that's only, 10% of my life doing that job on this machine. So then I can remove this, and when I'm doing repair work or when I need access to the chuck, it's not there. So this allows me that flexibility. Before, it didn't have this top piece and it didn't have this bottom piece. It just dripped straight on the floor. And this, and with our bigger coolant tank, this will kind of help get the coolant back in the tank. And then obviously this just gives me a narrow window here where coolant can shoot up, but this captures, I don't know, like 70% more fluid than when this was completely open and the wall had nothing. So this hopefully is gonna be really, really nice. And I can move this out of the way and then I can take it off when I don't need it, all right? That stuff may be adjusted in the future. This guy here basically is just to kind of bridge a small gap here, and also just kind of helps return some coolant in this area, so that way everything here kind of makes it back to the tank. There was actually a guard like that before. I think I tossed it, typical Kyle. Couldn't find it, but this one's kind of better and it looks nicer, kind of, you know, blends with the machine, has a nice bend. So that's in terms of coolant and guarding. The threading handle, I don't remember if we talked about this, but I modified it. Before, you had to stand over here and literally bend over like this to thread. That's a problem. I have this super bent handle that looks crazy weird, but it's great. I can stand right here and I can thread like this, and you can see my body position doesn't change. So when I'm threading, the ergonomics are great. I went ahead and fixed the issue with the nut being all tied up. I ran the machine back and forth, I think for 2 to 3 hours straight, and basically that nut was just, I don't know if you want to call it new or not worn in, but this action is a little bit smoother, or considerably smoother than it was, and it doesn't hang up. It goes into gear a lot easier. So we redid the way wipers. The way wipers from Lion are actually decent, but the problem is Daniel, when he redid the top slide, he had the gib sticking out about 1/4 inch, which is a good thing, a really good thing. That means as the machine wears, you have some room for the gib to slide in. Problem is, on this machine, and I don't know why they did this, you got like 3/4 inch of gib adjustment, which means that as the machine wears, you don't have a lot of travel for that gib to compensate. On other machines, you know, inch, inch and a quarter, inch and a half. This machine, 1/2 inch to 3/4, not very much. So that little 1/4 inch proud that screw sticks out just gives me more travel and life as the machine wears, which is great. Problem that created was these way covers kind of kicked out because there was a screw behind here that was proud. And I was running the way wipers like that initially, but I actually started to get some very minor drag marks on this beautifully scraped surface, and I realized that needed to be corrected. So I pulled these off. We actually did a felt way wiper behind the rubber to sort of double up, and I added 2 additional screw holes drilled and tapped, and I modified the back of this with a cutout, so that way everything lays flat and makes a difference in terms of squeegeeing this just a little bit better. And the little things really go a long way. In that same vein, I don't think I showed this, but this DRO cover on the back, it clamped up to the side and it had a slight gap. Not a big deal, you wouldn't think at least, but when we took this apart and we had damage, what I think was happening is I think that cast iron was falling through the crack on this, and it was kind of getting stuck by the DRO mount, because the DRO mount sits very close to the side of the casting. So you had this little spot for like dust from hot roll material and cast iron to kind of fall in there, and it kind of helped get it trapped. So what I went ahead and did is I took this off and I installed a piece of felt along the end, and I riveted it so that way when I took my L and it bolted it up, it creates a seal along the edge, which again, it's minor, but it hopefully will help mitigate some particles from kind of falling through. And so far in that area, it has been cleaner. Gib strips. So on this machine, when they installed it from the factory, the gibs were all improperly adjusted. And yeah, I don't even know. As an example, we went to take a heavy cut with your boy here, the Fix 8 holder. This saddle lifts like a 1/4 of an inch. Visually, you can see the saddle lift. Well, that's a problem, right? And the reason for that is the gib strips are not adjusted properly. Also, we're taking a heavy cut, but now there are 2 adjustable clamps here, but these clamps are for locking the carriage down. So in addition to those, there are actually strips back here that should keep the carriage from lifting up during heavy cutting. Well, the problem is they weren't adjusted properly in the back because there's an adjustment. So the carriage was able to move. So obviously Daniel fixed that. And then on the front, these are bolted, meaning that there is a clearance that is preset from the factory. So that way it can slide, right? But then it's limited on lifting up. And on the front, it's a little less critical because when you're threading in reverse or you're doing reverse ops, the front will be what matters, but then on the back is kind of what matters more when you're doing normal work. So we got the back squared, and then on the front, the typical clearance should be like 1/2 thou, maybe 1 thou, right, of lift, so it doesn't drag, but it's close. And on this side, it was like 14 thousandths. So this could lift up 14 thousandths under heavy cut. And on this side, it was 7. So we took these strips off, not the clamps, but the actual strips, and we machined off and we tested it with a feeler gauge. So now this operates smooth, no binding, but it's a much tighter fit, and hopefully it should be much more rigid during heavy cuts. And I can tell you we've done some boring where you will notice a lot of that, some heavy boring, 12 millimeter per side, and it does much better. Airlift, I want to show you it working, especially with the cable tray and everything. Airlift works great. It is a joy to use. You've seen a little bit of it in the airlift video, but I want to just show it to you. So right now, nothing. It's completely silent, right? Because the machine is off, as I intended it. So we turn the machine on. You probably can't even hear it over the spindle. It's a little bit of air, right? There's the solenoid, silent. Go to move it. So right now you can't move it, it's locked. Unlock it. All right, look at that. One hand, right? I got a hand on my phone. All right. And if you move it all the way back, you know, it slides really nice. And then you lock it. It's a dream. It is simply amazing. Now, as you see, that takes a little bit more effort than I would have loved, right? Because I'm a perfectionist and I wanted, you know, like 10 pounds of force. It's like 20, 25 pounds of force. But 20 to 25 pounds of force to move this is amazing. It makes the machine a joy to use. And because we have it set up with this guy, it's so seamless. That's most of the problems we fixed. So the first thing is this compound needs to be rescraped. True story, no exaggeration. You take the gib, he was here last time, you run the gib all the way in, max it out, you can still turn the dang thing. That's a problem. What that means is the taper on that and the thickness of the gib is basically wrong, right? So as the machine wears, you should adjust the gib in and it should be able to compensate for wear. So if I can tighten the gib all the way in and still move the compound, that means I'm basically at the end of the service life of the gib, and we haven't even started. This machine is brand new. I've used the compound maybe never. So it has 0 use on it and the gib is already too small. So he's gonna take it back. Daniel's amazing. He'll make it right. He'll bring it back to me. I consider this problem already solved. So he's gonna have to Moglease the gib, thicken that gib up. He's gonna rescrape in all the flats. He's gonna make it look good. It's done. That problem is already solved. In addition to that, we have one problem which I wanna get your feedback on. I think I know how I wanna solve it. When we started this project, the lathe had some minor issues, which some would argue are major issues in terms of the actual performance. So as an example, if you were to cut an 8-foot bar, which we did, and you started your cut at 4-inch on the DRO, by the time you finished that cut, it'd be at like 4-inch 13 thousandths. And the reason for that is not taper. The reason for that is that the cross slide will actually migrate 13 thousandths over 8 feet. And there's a variety of reasons for that. Looseness and adjustment and all that stuff. The lathe does not do that anymore. So that is a win. But what it does do, and I don't think I noticed this before, or we created it, one of the two, but the problem was worse before, so it was sort of blocking me from being more particular, is if I zero this DRO right now, I zero it, and I move this handle, right, and I shift it into gear, right, 0.06 tenths. That's not much, I get it, guys. But where that becomes a problem is when you're machining a bearing journal. Bearing journals are precise. So you make your machined cut, and when you machine, it doesn't move, which is a big, big deal. It moved before. You take your cut. Well, when you power feed out, which you do a lot on this machine, it moves. Right now it's at 8 tenths, and I literally have not touched this dial, right? Probably could get it, you know, to 1 thou error, you know, just by kind of moving it back and forth. You take your cut, and then you power feed out. This number is different than the number that you started your cut with by, you know, anywhere between 6 tenths and 1.5 thousandths. That's a problem because when you go to measure your part and adjust your DRO, the measurement that you're accounting for is not the measurement of the cut you took, it's the measurement that the DRO just adjusted. So in this case, before I make my inquiry into the DRO, I need to come back and re-zero this cross slide and then make my input. But the problem is when you're machining, it's not on zero, you know, maybe like 5 inches, 427 thousandths. So you got to remember that number. So when you finish your cut and you power feed out and it changes 2 thousandths or 1.5 thousandths, you got to remember what that number is, put it back, measure your part, and make your adjustment. It's super, super annoying, especially if you're trying to work accurately. The reason for that, and I know this sounds crazy, but when you put this into gear, there is a clutch in here. And what happens is there's a gear here. This is disengaged right here. So it engages and disengages this. So you can see it now. I don't know if you can see from here. But when I do this, that moved 8 thousandths right there. Just by engaging it and disengaging 9 thousandths, 10 thousandths. So this moved 10 thousandths without even touching it by just putting this into gear. All right, that is a major problem. The reason for that is when you put it in gear, there's a gear in here that interfaces and locks and unlocks this, and it just slowly migrates the lead screw forward or reverse. Like if you were going in reverse, it would be reverse, whatever direction you were last going in. And that gear just slightly bumps it, right? And I never noticed that before because of the other issues, but that's a problem. I did a bunch of research, and I messed with the nut and did a bunch of alignment stuff. Same thing. We changed the nut, we tightened up the backlash, none of it changed. So what I'm going to do is I'm going to add a little lock here, which you shouldn't really do, but I'm going to do it to basically tighten the gib when you're working towards the end, and that'll just keep this cross slide fixed. So that way that little movement doesn't move it, and then you can unlock it and all that. Anyway, if you guys got a better idea, I would love to hear it. But that obviously is a problem. Now, if you don't use this and you back out of the cut manually, it's not a problem, which tells you that it's something in this apron here. But when you're cutting a long part and you're running this machine, you rarely run with the handle out like a normal lathe. With the power feed, you power feed everywhere and make final adjustments. So you got to kind of use the lathe in a way that's not as convenient. Other than that, everything else is pretty good. Last thing, everyone's asking me if I talked to Lion about this, and I've been patient and I've been waiting because I didn't want to give you guys any false information. And you know me, I'm honest, and I'm going to tell you how it is. I'm going to keep it short and sweet. Lion is amazing. All right, I know people disagree with that after watching this 5-video series where we realized the build quality was not up to par, which is true. Lion, Johnny, the accountant, the tech, everyone in California, they do a really good job. And at the end of the day, I don't want to say their hands are tied because they're not. They could talk to the manufacturer, they could demand better quality, but the reality is the quality coming out of the factory is not where it needs to be, in my opinion. From Lion's perspective, they sell a machine, no one complains. Because guess what? Before the cross slide, it wasn't as smooth as it is now, but it worked. Cut good parts, right? So unless you pull your machine apart and do a double check, as a customer, you got a new machine, you're happy. You're not going to complain to Johnny, and Johnny's not going to complain to the manufacturer. So in Johnny's 30 years of doing this, I'm one of the very few customers that actually said, hey, we got problems here. So he wants to listen to me as a good sales guy and as a good person, but at the end of the day, one guy out of all these people complaining, it just makes me look bad, makes me look like I'm very particular. Now, in my defense, I believe that this is a precision machine tool, and that a precision machine tool is just that, precision. So this type of stuff that Daniel did, it's not A+ level work, and that's no offense to Daniel. Daniel's amazing. This is like B- scraping, right? Or B+, right? We didn't chase 40 points. We didn't go crazy. We got it flat. We moved on. It looks good. That's it, right? I know there were lots of machines built in the past to A level, A+, you know, all that kind of stuff. We got this machine to a respectable level, in my opinion, but that level is significantly higher than what they're putting out at the factory. And the reason for that is that people don't care. People that are buying these machines, they don't care, so they can get by with subpar work. And the other thing is in order to do this properly, it would cost another 10 to 15 grand, maybe even 20 grand, and the market isn't gonna pay for it. And I wanna be clear on that, because as much as I want this machine to be built to this level, because I spent, you know, 3/4 of what it costs to buy a Ferrari, you know, a used Ferrari, a house maybe. This machine is built to a price point because that's what the market wants. The market wants to save 15 or 20 grand and get a cheaper machine and then pay 15 or 20 grand more and have a machine that they're over here looking at the paint work and the scraping, and I totally get it. So at the end of the day, I'm not mad. I think if anything, it's my fault because I oversold myself on this machine. I did a lot of research. I talked to Josh, and at the end of the day, I have another unit that is built much better than this, in my opinion. I thought the machine was just a better machine than it is. The machine is a good machine, and it is a great machine compared to all the other trash on the market, which I've seen and run that's being put out today. It really is comparatively good. But when you spend that amount of money and you think it's a precision tool, you get pretty bothered. And I think at the end of the day, me spending 6 months, whatever it's been, that's probably the most frustrating part. Now granted, a certain percentage of that is upgrades, we'll say 50%, but still, we spent a fair amount of money and a definite amount of time getting this to what I believe to be a stock form in terms of scraping and, you know, fit up and all that. So that is what was frustrating. So they went and sent me some spare parts for the machine that were fairly expensive, $1,500, $2,000 parts. They sent them free of charge as a sign of good faith, and I do appreciate that. At this current moment, we're not using them because we have the airlift for the tailstock. It was like a tailstock assembly that we talked about getting earlier in the process as a solution. And I'm grateful for that, but they didn't pay to get all this re-scraped in. And I understand why they didn't. And you know, that's fine. So I wanted to share that with you because a lot of people are asking me about it. You know I'm transparent. I probably shouldn't have said anything, but I just like to tell people how it is. And honesty is my best and worst quality. Machine's great now. It is so much better than when it came to me. The devil is in the details. All these little things here and there. You know, from the start when we made a better chuck key to where we are now, the machine went from, it's kind of annoying but works to, yeah, I enjoy using it. That is worth the 6 months. So we're done with the machine. We're gonna move on to other machines and we're gonna move on to other stuff. And I hope you guys have enjoyed this series. I know this has been extremely long-winded, but I wanted to be detail-oriented. I wanted to share the truth. I wanted to tell people what we did so they can learn. So we'll see you guys in the next one.